Okay, guys, good day. And today we are going to discuss a new topic, which is all about the shear and moment in beams. So first, let's read first the introduction for this course subject. So the term beam, so i-define muna natin kung ano ba yung beam. So this refers to a slender bar that carries transverse loading. So again, a beam. So this is a bar which carries transverse loading. That is, the applied forces are perpendicular to the bar. In a beam, the internal forces system consists of a shearing force, ayan, and a bending moment acting on the cross-section of the bar. So guys, ito yung ating pag-aaralan for this chapter. Yung pagkuha ng shearing force and yung bending moment. Which is ito yung kakailanganin natin do sa susunod na chapter, which is the stresses in beam. So, do sa chapter na yun, meron tayong tinatawag na bending stress or flexural stress. So, ang kapartner niya dito is yung bending moment. And we have also the horizontal shearing stress. So, para doon naman, ito yung kailangan nating malaman or yung kapartner ng horizontal shearing stress. As we have seen in previous chapters, the axial and torsional loads often result in internal forces that are constant in the bar or over portions of the bar. But here in the study of beams, however, this is complicated by the fact that the shearing force and the bending moment usually vary continuously along the length of the beam. So, yung value ng iyong shearing and bending moment do sa beam is not constant or pabago-bago siya. Depende sa load ng ine-carry ng isang beam. So, dito sa chapter na to, there are a lot of scenarios. So, isa-isa nating ituturo yun. There are different type of beam. And at the same time, there are different type of loading. So, ang goal kasi dito is to learn how to get the shearing force and the bending moment at a certain distance or at a certain section of the beam. Pero most of the time naman, ang kailangan naman kasi dito is yung pagkuha ng maximum shear and maximum moment. Kasi doon natin i-design yung magiging beam natin. Okay? So the internal force give rise to two kinds of stresses on a transverse section of a beam. So the first one, normal stress that is caused by the bending moment. And number two, the shear stress due to the shearing force. This chapter is concerned only with the variation of the shearing force and the bending moment under various combination of loads and type of support. Knowing the contribution of the shearing force and the bending moment in a beam is essential for the computation of stresses and deformation, which will be investigated in subsequent chapters. Okay? So again, ito is kakailanganin do sa mga susunod na lesson or chapter dito sa core subject na to. Okay? So this time we are going to discuss naman or tackle the support and load. So beams are classified according to their support. So we have a simply supported beam which is shown in the figure 4.1a. So this has a pin support at one end and a roller support at the other end. The pin support prevents displacement of the end of the beam but not its rotation. So meaning yung pin mo, ang sinusuportahan niya lang is yung displacement niya. Or yung, kaya dalawa yung ano natin reaction. We have vertical and horizontal. Pero yung rotation niya or yung moment, wala siyang sinusuportahan doon. And then, the term roller support refers to a pin connection that is free to move parallel to the axis of the beam. Meaning, wala siyang horizontal reaction. So, vertical lang or perpendicular to the surface. Okay? Hence, this type of support suppress only the transverse displacement. A cantilever beam, so sige, pakita natin yung 4.1a. Ayan. So, under 4.1a, ito yung simply supported. Okay? So, meron kang pin sa isang dulo, meron kang roller dun sa kabila. So, the next type is yung cantilever beam. So, when we say cantilever beam, is built into a rigid support at one end with the other end being free, as shown in the figure 4.1b. The built-in support prevents displacement as well as rotation of the end of the beam. An overhang beam illustrated, okay. So, yung 4.1p, so this is si Cantilever Beam. Again, yung isang end niya is rigidly fixed, meaning even the rotation, meron siyang support or meron siyang uh, moment. Okay? It is preventing the moment. So, fixed nga eh. So, hindi siya talaga totally gagalaw. So, yung rotation niya is prevented also. Cantilever, yung isang end niya is overhang or walang support. This is suspended at the other end. Okay? And last will be 4.1c or the overhang beam. So from the term itself, overhang, so meron siyang portion na nakalawit. Okay? So basahin natin. So an overhang beam illustrated in figure 4.1c is supported by a pin and a roller support with one or both ends of the beam extending beyond the supports. So the three types of beam are statically determinate because the support reaction can be found from the equilibrium equation. So again, kapag sinabi nating statically determinate, the equilibrium equation is enough to solve for the unknowns. Kaya nating masolve lahat ng reaction niya. So itong mga figure na to, ito yung una muna nating itatakal. Yung statically determinate beams. Again, may iba't ibang scenario lang siya. It's either it is simply supported or cantilever. Ayan. Isang end is fixed and yung isa is free. Or overhang. So overhang, pwedeng both side is merong portion na nakalawit, pwedeng isa lang, or pwedeng yung kabila lang. Basta overhang, meron siyang portion na nakasuspend. Okay? So the next type of beam are the statically indeterminate. So we have the prop cantilever beam, we have the fixed or restrained beam, and last is the continuous beam. So basahin natin yung statically indeterminate. So first, ito nga, i-discuss rin dito is yung mga type of load na makikita dyan. So concentrated load such as P in figure 4.1a is an approximation of a force that acts over a very small area, or kapag nga concentrated load, it is acting at a certain point lang. So under figure 1a, ayan nga, ito yung example ng concentrated load. This is acting only at this point. Next, in contrast, a distributed load is applied over a finite area. If the distributed load acts on a very narrow area, the load may be approximated by a line load. The intensity omega of this loading is expressed as force per unit length. So this can be in the units of pound per feet, Newton per meter, etc. Or that is force over distance. The load distribution may be uniform as shown in figure 4.1b. So kapag sinabing uniform, ayan siya. So rectangular ang shape niya at a certain value which is omega sub O. So ito yung sinasabing uniform. And or it may vary with distance along the beam. So as shown in figure 1, 4.1c. So it is varying So coming from 0, it is increasing at a certain degree. So ayan. So that is considered to be non-uniform or varying along with the distance. The weight of the beam is an example of distributed loading or yung self-weight natin. But its magnitude is usually small compared to the loads applied to the beam. So sometimes yung self-weight niya or yung weight ng beam mismo is neglected. But sometimes it is indicated in the problem na you need to consider the self-weight of the beam. So isasama mo siya doon sa original loading. Okay? So, dito meron pa tayong yung uniformly increasing. Kapag sinabing uniformly increasing, this is on a shape of a triangle or trapezoid. So, sometimes kasi yung loading mo is parang ganito din. So, let's just say we have here a simply supported. Ayan. So, meron kang triangular uniformly increasing load. So, coming from 0 at ending at a value of omega. So, ayan, uniformly increasing. So, guys, dito sa shear and moment, napakahalaga dito yung pag-compute ng area. So, during the discussion, i-share ko sa inyo yung equation for nth degree curve, kung paano ba kinukuha yung distance ng centroid niya and yung pagkuha ng area. That is very important in this topic, for this topic. Okay? So let's continue. Figure 4.2 shows the other types of beam. So these beams are over supported in the sense that each beam has at least one or more reaction than is necessary for support. So such beams are statically indeterminate. So ibig sabihin, yung equilibrium equations mo is not enough to solve for the unknowns. The presence of these redundant supports requires the use of additional equation obtained by the considering the deformation of the beam. So yung additional equation mo is manggagaling dun sa magiging deformation ng beam mo. So that will be further discussed dun sa last chapter natin, which is all about the deflection. So the analysis of statically determinate beams will be discussed in other chapters. Okay, so next, the shear moment equation and shear moment diagram. So the determination of the internal force system acting at a given section of a beam is straightforward. So we need to draw a free body diagram that exposes these forces and then compute the forces using equilibrium equations. However, the goal of beam analysis is more involved. So we want to determine the shear force B. So yung symbol mo ng shear is usually denoted by the symbol V, capital letter B. And the bending moment, so this has a symbol of capital letter M at every cross section of the beam. So to accomplish this task, we must derive the expression for V or the shear and M moment in terms of the distance X measured along the beam. So ito, na-emphasize dito yung distance X. So ito is ginagamit kapag yung method na ginamit mo sa pagkuha ng shear and moment is using the sectioning method. So sa pagkuha ng or paggawa ng shear and moment diagram, meron tayong dalawang method. Una is the sectioning method and then pangalawa is the using the area diagram. So later on nga, as we progress in this chapter, so malalaman nyo kung kailan ba magandang gamitin itong isang method compared dito sa isa. And kailan ba yung instances na kailangan mo silang pagsamahin. Ano? So, huwag kayong mag-alala, yan naman na ituturo ko or ibibigay ko sa inyo yung mga tips and techniques sa pagkuha ng shear and moment. So, by plotting this expression to scale, we obtain the shear force and bending moment diagram for the beam. The shear force and bending moment diagrams are convenient visual reference for the internal force in a beam. In a particular, they identify the maximum values of V and M. Okay. So, sign conventions tayo. So, for consistency, it is necessary to adopt sign convention for applied loading, shear forces, and bending moment. So, we will use the convention shown in the figure 4.3 or ito yung table na to, which assume the following to be positive. So, the first one, external forces that are directed downward, external couples that are directed clockwise. So, next, the shear forces that tends to rotate a beam element clockwise. Okay? And last, the bending moments that tend to bend a beam element concave upward. So, kapag ganyan yung cases mo, so that is considered to be positive. So, ayan. So, the main disadvantage of the above convention is that they rely on such adjectives as downward, clockwise, and so on. So, to eliminate this obstacle, a convention based upon our Cartesian coordinate system is sometimes used. So, using this diagram, ayan. So, ito na lang siya. So, based on the external loads, so this can be considered positive if, first, your couple moment is clockwise. Next, you have a concentrated load, which is directed downward, and the uniform load, or non-uniform load, which is directed downward. Vice versa lang kapag negative. So, counterclockwise, couple, kapag yung concentrated load mong P is upward and so as for the uniform or non-uniform loading. So for the shearing force, guys, kapag nag-section ka and itong kapag itong kunin ko lang yung aking point. So let's just say for example, meron kang beam. Ayan. So kapag nag-section ka, guys, kapag itong right portion yung in-consider mo, ayan. So yung shearing mo, yung upward is considered to be the positive. Okay? And kapag itong kaliwang portion yung in-consider mo, eto, kapag nag-section ka, yung pababa is the positive. Okay? Or sabi nga dito, shear force that tends to rotate a beam clockwise. So isipin mo na lang ito yung gitna ng ano mo. So di ba yung ikot niyan is clockwise. Ayan. So and negative vice versa lang siya kapag ganito yung nagiging ikot niya. So kahit itong portion na lang nito, ang tandaan nyo. Next, for the bending naman, so ganun lang din. If ang i-consider mo is yung kapag nag-section ka is yung right side, so ang moment na positive mo is pa ganito. Ayan. And kapag left side, ito naman yung positive. Or kapag imagine mo yung beam mo, ayan, di ba parang based on this moment, ang nangyari sa kanya, naging smiley or concave upward. Ayan. So, if that is the bending moment, that is considered to be positive. Pero, again, may isa-share na lang din ako sa inyo kung kailan ba nalalaman na positive and kung kailan ba nakikitang negative yung shearing force. Okay, so sa tingin ko mas mauunawaan nyo siya. Kasi ito, medyo nalilito lang din ako dito before. So, I much prefer yung technique na naituro rin sa amin noon. So, kung yun yung positive or negative, upward and nakatayo and nakahiga lang. So, mamaya, i-ano natin yan. Mas maunawaan yung sinasabi ko. So last, for letter B, this is the procedure for determining shear force and bending moment diagram. So this is the step-by-step process na kailangan mong gawin para makapagawa ka ng bending moment diagram. So the following is a general procedure for obtaining shear force and bending moment diagrams of a statically determinate beam. So for the first one, compute the support reaction from the free body diagram of the entire beam. So, ayan, kukuha ka muna ng reaction. Step number 1, solve for the reaction. So, again, this portion, so this is for the part of static of rigid bodies. Equilibrium equation to solve for the reaction. Next, so you need to divide the beam into segments so that the loading within each segment is continuous. Thus, the endpoints of the segment are discontinuous of loading, including concentrated loads and couple. Perform the following steps for each segment of the beam. So ito guys, itong dinidiscuss na second step dito is kailangan mo siya for the method of sectioning method. So and every change ng load, kailangan mo mag-section. Pero mas madali yung yung isang method, yung area method. Okay? So magbe-base ka lang do sa previous diagram. So, step number 3, introduce an imaginary cutting plane within the segment located at a distance x from the left end of the beam that cuts the beam into 2 parts. Ayan. So, coming from the left end hanggang doon sa section. So, para bang lang yan, magsasection ka na magsasection base doon sa mga changes in loading. Okay? Next, draw a free body diagram of the part of the beam lying either to the left or to the right. So, ito, di ba kapag nagsasection tayo, tandaan nyo doon sa method of analysis of structure, sa analysis of stress, di ba merong a section method? Pwede yung gawin mo, it's either yung left side or yung right side yung i-consider mo. So parang ganito lang din yung application niya sa pagkuha ng shear and moment. So using design convention, ayan, so kakailanganin mo rin to. Okay? So, nasa na tayo? So, draw a free body diagram for the part of the beam lying either to the left or ito na nga yan. So, next, determine the expression for V and M from the equilibrium equations obtainable from the free body diagram. So these expressions, which are usually function of x, are the shearing force and the bending moment equation for the segment. So ang main goal mo dito is to make an equation in terms of x. Kasi yung x mo nga is the distance away from the left support papunta do sa right. Ano? So there are several equations nga na ma-establish mo dito. Again, based on the number of section na ginawa mo, ganun din karaming equation yung gagawin mo. So nakailang beses ka mag-change ng load dyan, so ganun din karaming equation na gagawin mo. That's why ang sabi ko nga, sometimes kapag ganun yung case, mas maganda na gamitin yung area method. The sectioning method is maganda gamitin kapag yung loading mo is uniformly varying, or pwedeng triangular yung loading mo, yung uniform load mo is in triangular shape, or pwede ring at an nth degree. So dito ko ginagamit yung sectioning method. Ayan. So, okay, mag-alala. Ituturo ko rin siya. Then last, plot the expression for shear and moment for the segment. So it is visually desirable to draw the shear diagram below the FPD of the entire beam. And then draw the moment diagram below the shear diagram. So ang ibig sabihin niya lang dyan is kapag may beam ka, ayan, ito yung original loading mo. So ang sunod na diagram na gagawin mo, so this is for the shear diagram. And yung after the shear diagram will be the moment diagram. So dito, mahalaga yung degree of the curve. Kasi ang mangyayari lang dyan, if this is rectangular, ang mangyayari, di ba ang rectangle is a 0-degree curve, magiging first degree, and then last will be a second degree. So magiging +1 lang siya ng +1. Ano? So the shape of the shear and moment diagram is important. Kasi at the end, do sa moment diagram mo, yung moment diagram, ang sunod na diagram dyan is yung shape ng kanyang deflection. Kabaligtaran lang siya ng shape ng moment diagram mo. So again, importante yan, lalo na sa susunod nating chapter, which is the stresses in beam. Kasi kapag sa stresses in beam, doon mo malalaman kung alin yung nag-undergo ng tensile stress and kung alin yung portion na nagkaka-experience ng compressive stress. Okay? So, don't worry. As we progress nga, again, unti-unti nyo maintindihan yung sinasabi ko. Okay. So, I think this is the last page. So, let's try this on an example.